Good evening, everyone. Today, we're going to cover some very important models from areas related to circle. First, few selected questions from textbook and then from different books. 15th question. ABC is a quadrant of a circle of radius 14. So, if ABC is a quadrant, angle A is 90 degree. Radius is given as 14, so AB is 14. AC is also 14. Semicircles are drawn with BC as a diameter. With BC as a diameter, semicircles are drawn. But the semicircle is this one. This is a semicircle, not the white one. Find the area of the shaded region. Now, area of the shaded region is, first, let us find the area of the right angle triangle. And then find the area of the quadrant and then find the area of the right angle triangle. Quadrant minus right angle triangle will give you this segment, this area. Then find the area of the semicircle minus area of the segment will give you the area of the shaded region. So here it is. So first thing, we are finding the length of AC, which forms the diameter of the semicircle. Since ABC is a right angle triangle, OA square plus OB square equal to AB square. 14 square plus 14 square equal to AB square. Don't waste time by squaring this. Instead, just add it directly. We get 2 times 14 square. So AB will be root over 2 times 14 square, which is 14 root 2. Mind you, AB is a diameter, not the radius. So directly divide that by 2. With that, you get the radius as 7 root 2. So AB is a diameter, the radius of the semicircle is 7 root 2. Now, the procedure to do it, first finding the area of the segment, which is area of the quadrant minus area of the triangle. Then area of the shaded region is area of semicircle minus area of the segment. So area of the segment is area of the quadrant, which is 1 by 4 pi r square. R is given in the question, so applying that. And area of the triangle being a right angle triangle, half into base into height. With that, we find the area of the segment as 56. Area of the shaded region is area of the semicircle minus area of the segment. Semicircle is pi r square by 2. R, we found it as 7 root 2. So apply that. Minus the segment, which is 56. This way we find the area of the shaded region, which is 90. So the next is question number 16, wherein we need to find the area of the design. The design region I have shaded here. Half of the design region has been shaded in brown color. So to find the shaded region or the design region, its area of the quadrant, that means the one that has been highlighted in red color, minus the area of the right angle triangle, the one that has been highlighted in green color. So area of the quadrant minus area of the right angle triangle will give you area of this segment, which has been shaded in brown color. Now into 2 will give you the total area of the design. So that's what done over here. 2 times area of the quadrant minus area of the triangle. Quadrant radius is already available in the question. So put the values as instructed in the question. Base and height is also given. Simplify and get the answer. So since NCRT is over, we are getting into the extra models from areas related to circle. The one which I'm going to discuss now are mainly 2-mark questions and 1-mark questions. First one, find the perimeter of the given figure where AED is a semicircle and ABCD is a rectangle. The figure is this. Find the perimeter. Now, what is generally perimeter means? Sum of all sides, just measuring the outer boundary of a given figure. So that is AB plus BC plus CD plus arc length of AED. Since AED forms a semicircle, this arc length will be this perimeter of a semicircle. So it is pi r. Perimeter of a circle is 2 pi r. So for a semicircle, it's pi r. And r is half of BC. BC forms the diameter, or AD forms the diameter. So radius becomes 7 then. So Answer for this is 76 centimeter, which is AB plus BC plus CD plus pi r, which is arc length of AED. Substitute r is 7, you get 76 centimeter. Next question. A bicycle wheel makes 5,000 revolutions in moving 11 kilometers. A bicycle wheel makes 5,000 revolutions in moving 11 kilometers. Find the diameter of the wheel. So according to the question, the total distance covered by the wheel is 11 centimeter, which is equal to 11 lakh centimeter. 11 kilometers equal to 11 lakh centimeters. You can either keep it in centimeter or you can make it to meter also. Number of revolutions as per the question is 5,000. Distance covered in one revolution equals the total distance covered by the wheel divided by the total number of revolutions it has made. So distance is 11 lakh and the revolution is 5,000. Dividing this, I am getting 1,100 by 5. Distance covered in one revolution is also equal to the perimeter or circumference of the circle, which is 2 pi r. Hence, 1,100 by 5 equals to 2 pi r. So we need to find radius. So after you calculate, you find r is 35. And what is asked in the question is diameter. So 2 times r, which is 70 centimeter. Third question. The diameter of the wheel of a bus is 90 centimeter, which makes 315 revolutions per minute. Determine its speed. Now, distance covered in a revolution is equal to the perimeter of the wheel, which is 2 pi r. Diameter is given as 90, so radius is 45. So distance covered in a revolution or in one revolution is equal to 2 into 22 by 7 into 45. Then distance covered in 1 minute by making 315 revolution. Distance covered in 1 minute in making 315 revolutions equals the distance covered in one revolution into 315, which whatever is possible to cancel, I've cancelled it out and I kept it in this one. 44 into 45 into 45. No need to simplify now and then, just simplify only in the end. Distance covered in 1 minute is what we found, and it's kind of a very big number. So let's convert this to hour. So distance covered in an hour, I multiplied it by 60. Then whatever I get here is in centimeter because the radius is in centimeter. So the unit over here is centimeter, which means it's again a very big number. So converting it to kilometer. So I'm dividing by 1 lakh to convert the distance which is in centimeter to kilometer, which works out to 53.46 kilometers. So that means distance covered in making 315 revolutions in an hour is 53.46. So now speed is equal to distance by time. Distance covered in making 315 revolution in an hour is 53.46 and time is 1 hour, because we convert in speed is generally expressed as kilometer per hour or meter per minute. So if you wanted to maintain in meter per minute, you don't need to multiply there by 60. Okay, you can either maintain the speed in meter per minute or kilometer per hour. I'm going for kilometer per hour, so I'm dividing it 53.46 kilometer by 1 hour. Therefore, the speed is 53.46 kilometer per hour. Question number 4. Again, based on the revolution models, the diameter of the wheel of the bus is 140 centimeter. How many revolutions per minute must the wheel make in order to keep a speed of 66 km per hour? So here we need to find the number of revolutions per minute. So diameter of the wheel is given as 140 centimeter. So radius becomes 70 centimeter. Distance covered in one revolution is the perimeter of the circle or perimeter of the wheel, which is 2 pi r, works out to 440 centimeter. Speed of the wheel is given as 66 kilometer per hour. So this is the breakthrough. In 66 kilometer per hour means in 1 hour it covers 66 kilometer. That means in 1 hour it covers 66 lakh centimeter. Why centimeter? Because the distance covered in one revolution is in centimeters, so I prefer to keep this also in centimeter. So in 1 hour, 66 lakh centimeter. That means in 60 minutes, 66 lakh centimeter. Therefore, in 1 minute, 66 lakhs divided by 60, 1 lakh and 10,000 centimeter. So this is the distance covered by the wheel in 1 minute. Number of revolutions per minute is equal to the total distance it has covered in a minute divided by distance covered in one revolution. So 1 lakh and 10,000 divided by 440. We get 250. So total revolutions made is 250 revolutions. Question number 5. Find the number of revolutions made by a circular wheel of area 15.4 meter square in rolling a distance of 176 meter. So distance totally covered by the wheel is 176 meter. And the area of the wheel is given. Normally radius or diameter will be given, but instead area is given here. So from area we will find the radius first. Area of the circle is pi r square. 1.54 equal to pi r square. And then with this we find r as 7 by 10. Avoid keeping the values in decimals. Prefer to keep them in fractions always. So r is 7 by 10 meter. Distance covered in one revolution is again perimeter of the wheel. 2 into 22 by 7 into 7 by 10, which works out to 22 by 5. So total distance is equal to, given in the question as 176 meter. The wheel covers 176 meters totally. Number of revolution equals total distance covered divided by distance covered in one revolution. So 176 by 22 by 5, that works out to 40. So total revolutions or number of revolutions it is made is 40 revolutions in order to cover a distance of 176 meter. So that's it. We finished a very important sums. Yes, we have finished a very important sums based on rotation, wheel rotation models. This is a super important topic for some area related to circle. Once you finish doing it, watching the video, rewind and do the sums once again. And once you're clear with the concept, I think you can do any number of questions based on this. Thank you.